So what we will do, um, oh, what happened? Okay, so let's discuss this. Everybody please contribute, okay? These are known things. First of all, we'll talk about inverse functions. This is from the beginning. Okay, so I decided 30 minutes revision and then 30 minutes we will discuss rigorous questions. Inverse functions. Okay, so what is the inverse function? Quick, whoever knows. What is the inverse function? Just tell me your idea. Don't waste your time. If you are silent, I might think, okay, nobody knows this topic. What is the inverse function, guys? Don't know?
The opposite of the equation.
Say again?
Like the opposite of the equation.
Can't hear you. The opposite of the equation? What?
Yeah, sort of like that. Like just the flip of it.
Okay.
So like if the function was fx, then the inverse function would be f to the power of negative 1x.
Okay, so that's fine. But why this inverse function is important? That's what I'm asking. Okay, so everybody forgot this. Okay, look, there are functions, power functions, understand? Power functions, logarithmic functions, exponential functions, inverse functions. There are many types of functions, okay? Okay. Exponential functions, log functions, power functions, inverse functions. These are the functions you have to know. Right? If someone asks you to summarize what are the functions you know, these are the functions you know. Exponential functions, log functions, power functions, and inverse functions. Even for VCE, this is what you need. Now today we are going to discuss inverse functions. So later we will discuss exponentials, log, and power from the beginning. Okay. So when it comes to inverse function, what is an inverse function? So Karthik told me if fx is a function, then f dash x is f inverse function is this, f inverse. Now I'm asking, that's fine, but this is just renaming, right? So these are just names, right? So if you want, you can say this is gx. Okay. So you can say fx is a function, f gx is the inverse of fx. Okay, I hope you understand it from the beginning. F inverse x is the inverse function of fx. Right? So this is what typically we say, but one can say that gx is the inverse of fx. Now what I want to convince you, if fx is the function, f inverse x is like this, right? And that is the inverse, right? But if you rename this one, this to be gx, right? This to be gx. Now what I am saying, f inverse x becomes gx, right? So if someone says, there can be a question in the exam, gx is the inverse function of fx. So then you have to understand that gx is nothing but f inverse x. That f inverse x is just a name. Fx is a name. We understand f inverse x is an inverse function. Fx is the normal function, right? This is our normal function. This is our inverse function. This is our inverse function. So here, same thing, right? Inverse function. Okay, now rethink what is inverse function. How do you precisely know what is inverse function? How do you precisely know what is inverse function? Knowing f inverse x is inverse function is not satisfying my question. Telling me elephant is a black is not going to satisfy the question what is elephant, right? So anyone? How do you precisely convince yourself, oh, if this happens, this is inverse function? How do you precisely convince me that? Okay, before you go into that, please ask questions, okay? Please, I'm going from the beginning again, yeah? Because I have time to do these theories like 100 times, okay? But I need to touch the right depth as well, okay? So I can't teach you from the surface. So, okay, before we go into that, I would like to teach you this. Composite functions. Okay, composite functions. What is a composite function? Oh, there is another one. I need to put here, composite function.
A function inside a function.
Very good. Composite function is function inside a function. Example, if fx is equal to x squared plus x, gx is equal to x plus 2, right? What is fgx? Right, so this is called composite functional structure, right? So this is a composite function. Why? You can see function inside the function. You can see that, right? Typically you write that f0gx. Understand the notations, right? Composite function means function inside a function. Now, how do you look at it? Look at this gx. Gx is taking the place of x, right? See, look at that. Gx is taking the place of x. So wherever you have x here, right? Wherever you have x here, gx is replaced. Wherever you have x here, gx is replaced, right? So your answer would be gx squared plus gx. So you know gx is x plus 2. So it's going to be x plus 2 squared plus gx again x plus 2. So that is the composite function, right? That is the composite functions. Any questions? Any questions? Okay, all good? Okay. So I don't want you to have any conceptual problems after these lessons, okay? Okay, next one. Now think about g of fx. Is it a composite function? Yes, it is a composite function. Why? Because you can see that this is function inside a function, right? This can be written as g0 fx, right? So now what is happening here? Fx is taking the place of x, right? Here. Fx is taking the place of x, right? So it should be, sorry, fx plus 2. Fx plus 2. Right? So fx is what? X squared plus x plus 2. And that's the answer. You got it? Everyone? Prithvi, Dihan, all good? Everyone good? Shrish, all good?
Yeah.
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 Okay, good. Now look at F0G first. Okay. Look at F0G. F0G, right? That would be what is that? Yeah, let's see. X plus 2 square plus x plus 2. Okay. G0F, what is that? X squared plus x plus 2. So this is the summary, right? This is the summary we have now, right? Okay. So this is the summary we have now. Okay, all good, I guess, yeah? Okay. Now by looking at this, okay, by looking at this, what you can think? By looking at this, you see that F0G is not equal to G0F. Can you see that? Those two functions are not equal, right? And this is a very important thing to know. F0G is not equal to G0F. Okay. Now I'm going to teach you one important connection here. Look at the connection here. Mathematicians thought, is there a way, is there any possibility that F0Gx is equal to G0Fx? Mathematicians thought, is there any possibility, right? This can happen. Okay, I hope you understand the story. So any thinking?
Isn't it when they're inverse functions?
Very good. That's the connection. That bridge is very important, right? So understand that. Now they figured out, yes, we can have the above relation if Gx is the inverse function of fx, right? So what it says, f0g is equal to g0f is possible if gx is equal to inverse of that. Okay, so this is possible, right? So this is possible, the equality is possible if this one is f inverse x, right? So this is f inverse x. So that's what the story is. So connect the bridge, have the connection. So I'm doing it from the beginning. Ask me any specific questions, because tomorrow I will tell you how big is this VCE paper this year, and these things are damn important. Okay, nothing is easy, but I'm here to help you. Just it's your initiation. Just ask me if you have any questions. Okay, well, good. So in general, f0 gx is not is equal to g0 fx. That is true. But f0 gx is equal to g0 fx if gx is f inverse x. So that is what I taught you now, right? Then you can say f0 f inverse x is equal to f inverse 0 fx, right? So this can be written as f inverse x f inverse fx. So this is the thing that you may be missing in your knowledge. Okay, so this can be the thing maybe you are missing in your knowledge. Okay, okay, so right, try to understand these things. Okay, all good. And the next one, definition of inverse function. Definition of inverse function. That would be f0 f inverse x or f inverse 0 fx is equal to x. That's the definition, right? So you can have this here, and this is important, that is equal to x, right? So anyways, I'm going to send you this note, okay? And also I'm try to record this and send it to you. So it's just, you don't have to do anything, it's just answer these questions, okay? Okay. Good. Next one, properties of inverse functions. Properties of inverse function. Okay, first property. Who can tell me the first property?
It would be like fx is equal to f inverse x, or f minus x.
Can't hear you.
Fx is equal to f minus 1 to the power minus 1x first.
That is not a property, right?
Aren't they
There
both,
should be one-to-one function.
Say it again.
There should be one-to-one function.
Very good. The first property would be inverse functions are one-to-one. They are one-to-one functions. What is a one-to-one function, guys? What is a one-to-one function?
doesn't it mean that every value is unique?
Every value is unique. What do you mean?
So like every x value has its own y value, and every
Yes, that's right. So that means every x value has a unique y value. Every x value has a unique y value. Example? You have two functions like this. Right? So how do you check whether they are one-to-one? Horizontal line test. You make a horizontal line. horizontal line test. You make a horizontal line and see how many intersections are there. So there are 2 intersections, here you have 1 intersection. So this is not 1 to 1, this is 1 to 1. Right? So that's how you understand whether it is a 1 to 1 function or not, because if you get a complicated function, this is the technique you have to, okay, this is the technique you have to follow, guys. Okay, all good. Next property. What is the next property, guys?
Aren't they symmetric around y is equal to x?
Very good. They are symmetric. They are symmetric around y is equal to x, right? So it will be like this, right? So if you have a function like this, it will be like that. So this can be fx, and this can be f inverse x, or this can be fx. If that is fx, the other one is the f inverse x, vice versa. Can happen in both ways, right? In generally, I'm speaking here. When we get a specific question, we can think about that. So in inverse functions, how many properties are there? 2 properties, 1-to-1 function and symmetric property. Yeah, so this you have to understand, this you have to keep in your mind. Okay, right. Next one is how to find the inverse function. How to find the inverse function? I told you this. Okay, for example, suppose fx is equal to x squared. You need to find the inverse functions. I told you this is nothing but y, and then you swap x and y, right? So x is here, y squared here. Then what you have to do? Subject y. So if you subject y, you get this, right? Plus and minus square root. Got it? So now you get fx function is x squared, right? F inverse function is plus and minus x square root. So my math is 100% right? Why? Because when I take the square rooting, plus and minus should be involved, right? I'm not skipping anything. I'm just leaving it there. So we'll see what drama is coming after. Now, this is how you find the inverse function. Inverse functions should satisfy their properties, 1-to-1 and symmetry property around y is equal to x, right? So we'll try to plot it. Okay, plot. Okay, plotting is like this. Okay, so you know y is equal to x squared is like this. Okay, then what about square root of x? Square root of x is like this, right? And negative square root of x is like this. Now what is this one? Positive square root of x. What about this one? Negative square root of x. Right? So what about this one? The blue color one? X squared, right? Now this is the problem we have. Now what is y is equal to x? Y is equal to x should be like this, right? Okay. Now I will leave the problem for you. So now by looking at this, comment. We found the inverse function. We plotted that. Now tell me if you are going to agree with something or not. I'll give you a minute. So if something is suspicious here, we can discuss. Yeah. Anything?
So does it have to be a domain?
What do you mean? Specify that. Specify that.
Do we change the domain?
Okay. So the way I drew this x squared, x squared is not 1 to 1, right? Yeah. Okay. So now this is how we do this discussion. Okay. Look. If you think about x squared, it looks like this, right? Is it 1 to 1? No. Why? Because do the horizontal line test. See, it is not. So we can't talk about inverse function with x squared, right? But if you restrict this function like this, if you restrict the function, I think that this is what he was talking about, then you can use that, right? Okay. Then what you can do is you can disregard this part, right? If you disregard that part, then you have the other part only, right? So that means you have this part only. Okay. So 1-to-1 problem is done now, right? So the next one would be the symmetry, right? If you think about the symmetry, this is what it is. Okay. This is what it is. Okay. This is what it is. So, right. So you are going to disregard this part, right? So now those two functions, they are inverse to each other, right? So what I'm saying, once you find the inverse function, you have to filter out the right function so that they are 1-to-1, right? So this one. So this is x squared, this is square root of x. Now you understand, when you are defining x squared, you have to give the specific domain. Domain means x values, right? So you can say from 0 to infinity, right? Because starting from here, right, 0. Here you can say again from 0 to infinity. So under those domains, they are inverse to each other. Okay, any questions? I explained everything here. You just try to understand. Understanding level is different from student to student. But I hope all of you are very brainy students. Right, I know that. Try to catch it to the right depth. Okay, all good? Okay. Now what I'm going to do is this. So I need to be a little smart now, right? So what I'm going to do, I erase this part and this part, right? So I'm going to take those two parts now. Okay. So if I take those two parts, right, if I take those two parts, it would be like, oh, I don't have enough space here, guys. Okay, I don't have enough space here. It would be like this, and it would be like this, right? So now what about the symmetry here? Yeah, symmetry holds true now for that, right? So this is minus x square root. This is x squared, right? But this symmetry holds true for those two. Again, you have to define the domain, right? So this is again x0 to infinity. 0 starts from here. This is x-axis, right? So what about this one? That one would be x is from minus infinity to 0. Right. I hope you understand that. So we filtered out the domain according to the inverse function necessity. Any questions? Take the opportunity to ask the question and understand, okay? See, this one, this weird function, we sort of divide into two pieces so that those two pieces are going to satisfy the properties of inverse functions. All good, guys? Yep. Okay. Then that lesson is done. Inverse function is done. That's it. It's just 10 to 15 minutes. We're done, right? Next thing, so I hope you are making connections, okay? So what is the inverse functions and everything, okay? So I will send you the note and then you sort of go through it. Huh? Okay, next one is domain and range. Okay. So what is the meaning of domain and range? What is domain? All possible x values. What is range here? All possible y values. Right? All possible y values. Small example. Suppose y is equal to x plus 1. Alright. I'm going to give a domain from 0 to 5. From 0 to 5. That means I'm going to draw this, right? So I'm going to draw this from 0 to 5. If you have 0, it's starting from 1. If you have 5, it goes to 6, right? So here. Right? Like that. Okay. So it's 1 here, 6 here, 0 here, 5 here. Now you can see here, x domain means this, right? 0 to 5, this. All possible x values. Now what are the all possible y values? These are the all possible y values, right? So that can be written as 1 to 6, including. It's very easy. What's wrong with that? Okay. Now, how do you write it? Y 1 to 6 like this. Okay. So this is a very easy example here, right? So the functional notation of writing a function, right? So I'll teach you that here. functional notation. Functional notation. Okay, suppose you have a function. Okay, suppose you have a function y is equal to y of x, okay, is equal to x plus 1, right? Then you are given the domain from 0 to 5, right? All the details are here, from where to where x is changing, what is the function, how do you plot it, and all the details are there, right? So when these details are here, you can eventually find the range, right? Range should not be given. Range should not be given. We can find it. How we can find it? Plug the values in, right? So like here, you put 0 value here. Okay. So plug the values in. So what you do, typically I'll tell you what you do. This is called the lower boundary of x. Lower boundary of x. Okay. This is called upper boundary of x. Okay. Lower boundary of x and upper boundary of x. Okay. So now you understand from this picture here. So this is the lower boundary, this is the upper boundary, right? So it's very easy. Yeah. Then how to find the range? Always we do this, even in VCE we do this. What we are going to do, we are going to put your lower boundary first into here, right? So 0. So once you put x is equal to 0, your y value becomes 0 plus 1, 1. When you put 5 here, then x is equal to 5, right? X is equal to 5, so its y is going to be 6 here. So your y would be 1 to 6. Okay, so that's how you find the range. So the range shouldn't be given to you. You can find it when the domain is given, right? Okay. Next one. Then how do you write this these things in functional notation? This is how you write f double dot. That means the name of the function is f. Then here you put the domain. Always it is R, always. Then the function. Sorry. Yeah. Always. Then the function fx is equal to blah 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 blah, whatever the function. This is the what do you call it? This is the format. Okay. So now how do you write this one? You write f double dot. It is going to be from 0 to 5. Right, and then it's R fx is equal to x plus 1. This is our functional notation. So in exams, in other papers, you will have these you will have the functions defined in this way. Okay, so we have to know what is what then. Okay, example, if gx is equal to x squared, defined from 0 to infinity. Okay, how do you write this in functional notation? How do you write this functional notation? It's easy. Again, g double dot. Then you have to put the domain, right? Domain is 0 to infinity. Always that r should be there. R means real, okay? Real value. This r means real value, okay? Comma. then gx, then you write the function which is x squared. Okay, easy peasy. Okay, easy peasy. So in the future you will get questions like this. You will get functions like this, fx from 0 to 2 pi r fx is equal to sin x. See, same thing. Domain is given, function is given. Range shouldn't be given, right? So you put the lower boundary and upper boundary. This is your lower x boundary. This is your upper x boundary. Okay, all good. So that is range and domain and range. Not a big deal, right? So maybe you can catch it now very fast. Why? Because you have seen something, right? And you have gone through, these things. Yeah. Okay. So this is range and domain. Okay. So any questions so far? So inverse functions completely we discussed, right? And range and domain we completely discussed, right? Yes, it is true. And composite functions. Composite functions we discussed, right? It's a function inside a function. That's it. What we have to discuss is exponential functions, log functions, and the power functions that we will be doing in the later time. Okay, so in next few lectures I will be discussing those things, so then you will be brushing up the things from the beginning again and again and again. So if you miss something, you have the chance to restore everything again and again and again and again. Okay, so yeah, so that's the goal here. Okay, all good. Okay, so going back to our class test. Okay, I would like to discuss question number 3. Question number 3. So question number 3, okay, look at how I'm doing it. I will sort of formulate that so that you can do the rest of the part. Okay, so cos squared x plus 1 divided by square root 2 plus square root 3 divided by 2, right? Sin x minus 1 minus square root 3 divided by 2 square root 2 is equal to 0. X is from 0 to pi is given to you. Now, is this a easy question? No, hell no. This is not an easy question. These questions are given to you so that I can improve your thinking. Okay, so that's the purpose. Okay, so hard medicines are bitter, you know that. Anyhow, there is a hint given to you, cos squared x, right? So what is cos squared x? Okay, let's think about this. Cos squared x plus sin squared x is equal to 1. So this is your first trigonometry identity. Trig identity. In math method, you have this identity. If you do specialist math, 100% you have to use these things. Even math method, you have this, and you guys are targeting row 45 plus. So that's why I'm teaching you all of these things. Okay, otherwise I'm not making any jokes here. So cos squared x can be converted into sin squared by using this trig identity. So cos squared x is equal to sin squared x plus 1, minus sin squared x plus 1, right? Blah blah blah. Okay, so you have these things, right? So this plus, so I have to copy this. Okay, sin x minus 1 minus square root 3 divided by 2 square root 2 is equal to 0, right? Okay, so now what I am going to do, I don't like this minus in front of sin squared, yeah? So I'm going to multiply the whole equation by sin squared, yeah? So it's going to be sine squared x minus 1. So I put minus here. 1 divided by square root 2 plus square root 3 divided by 2, right? So sine x, and then plus 1 here, plus square root 3 divided by 2 square root 2 square root 2 square root 2 is equal to 0. Okay. Is there any hard math here? What did I do mostly? Copy pasting. Did I do any intellectual math here? Hell no. It's just copy pasting, right? And then if you are here, what I did, I multiplied the whole equation by minus sign, which is grade 2 math. Okay, so that's what I did. Now what I can do, see, I can get rid of these two. Easy. The question is designed so that these cancellations are happening. At the same time, you have to think in the VCE paper, you know, that panel is a very smart panel, right? So they will give you some killer questions, but end of the day, the things are coming very smooth, okay? So you will expect those things in the future. So sine squared x, okay, let's see now this. Okay, minus, okay, I will be a little smart here. 1 divided by square root 2, okay, okay, plus square root 3 divided by 2, okay, sine x. By looking at this beast here, right, by looking at this beast here, what I will do, I will write this one as 1 divided by square root 2 times square root 3 divided by 2. When I see this structure. When I see that structure, right? So all of the structures I taught you, but you know, but okay, so this is the life. So x squared, you remember I told you if you have alpha plus beta x plus alpha beta is equal to 0, what would be the answer? X minus alpha, x plus alpha, x plus beta. You can factorize it like that. Did I teach you that? I taught you that in quadratics, right? But I don't have to teach you this. When you are in grade 6, 7, you have done this. 5x plus 6. This is nothing but x squared plus 2 plus 3x plus 2 times 3. So naturally, you can say x plus 3, x plus 2. Right? So the teacher who taught you this bit when you are in grade 6, she might have taught you this. Now we are going to take that structure into this business and then you can factorize it. Now, what if you have x squared minus alpha plus beta, x plus alpha beta? Right? So these are the things that you have to do at home. Right? So if you have that, it would be x minus alpha, x minus beta, yeah? Easy. You got it, everyone? Yep. So now this is just a background, right? So this is just a background, right? Now, I gave you that background so that those things are coming in here. Can you see? This is how the VCE's training is happening. Unfortunately, most of the kids think, oh, I just need to do this. If I know this, I'm very happy. Even this is very hard, but still can manage. No, these are very babyish kind of math you have in your textbook. This is the VCE kind of a training. Okay, so I hope you understand what I'm saying here. Okay, now okay, so now how do you factorize this? So by looking at that, you can say this is sine x minus 1 divided by square root 2 sine x minus square root 3 divided by 2 is equal to 0. See, that's the beauty. The question is designed So you are connecting many things and sort of simplifying it elegantly. Any questions? This is the level you have to reach, okay? So I'm going to give similar questions again and again and again. So you bring yourself into that level, okay? Because I'll tell you one thing, VCE, there are few patterns they are looking at. There are no infinite number of patterns they are going to put in. There are finite number of patterns that they are going to give questions, right? All the patterns will be trained here under Dr. U. But unfortunately, those patterns are this rigorous enough. But I can't help, right? That is VCE. I didn't design those things, right? So, eat it. What I can say, what else I can say? Okay. Now, what is this here? Null factor law, NFL. So, if you have null factor law here, so you get here sin x is equal to 1 divided by square root 2. The other one would be sin x is equal to square root 3 divided by 2. And I think the domain is given, right? 0 to pi. X is 0 to pi. Now game is easy peasy, yeah? So you take this, it's sine. Just plot the sine from 0 to pi. It's going to be here. Again sine here, it's going to be here. So it's 1 divided by square root 2, it's here. So there are two solutions here, 1 and 2. Right? So here it's square root 3 divided by 2. These lessons again I will be revisiting, okay, but absorb as much as you can, right? 4 solutions we are expecting, right? So here it's going to be pi divided by 4, and then this is going to be pi minus pi divided by 4. Here it's going to be sine 30, sine 60, pi divided by 3, so it's going to be pi minus pi divided by 3. So the answers would be x is equal to pi divided by 4, comma 3 pi divided by 4, comma pi divided by 3, comma then you get 2 pi divided by 3. That's the end of the question, guys. So this is what I was testing, right? So if you honestly look at that, it's just how many steps? 1, 2, 3, 4, 5 steps, because this is just my explanation, right? So this should be in your head, right? Okay, so if you have the skill up to this mark, if you know what I did here, if you can reproduce this, man, you are in. Okay. Okie dokie. Oh, where is Tehasna today? Oh, Tehasna is not here today. Okay. Okay, so I'll give you a question, a similar question, and we'll see how you do this, okay? Okay, give me a minute. I need to construct this question. Give me a minute. Okay, let's see. 1 second. Give me a second, I need to construct it. Okay, so I will make the life a little easier and try to do this question. Solve cos squared 2x plus 1 divided by 2 minus 1 divided by square root 2 cos 2x minus 1 divided by 2 square root 2 is equal to 0. X is from 0 to 2 pi. Okay, try that. And then cos 2x here. Don't worry what you have inside. It's just you have that, right? So make cos 2x maybe k. Then convert that into a known format. These are, usual strategies, okay? These are not, something impossible. So everybody is able to do these things. So understand that. So quadratic, but quadratic is coming in cos form, seemingly complicated. Have the intention to convert that into in terms of k from that by that substitution. Okay, then this is nothing but what? This is nothing but 1 divided by 2 times 1 divided by square root 2, right? So this is nothing but again k squared plus alpha minus beta k, right? Alpha plus beta plus alpha beta, that structure. So you can write this one k, okay, plus half, okay, k minus 1 divided by root 2. Done. Understand what I did? Any question? Any question here? Method, all good? Method, all good. Now from here, null factor law, right? And NFL. So k is equal to minus half and 1 divided by square root 2. Okay, so now what is k here? Cos 2x. That's it. See, this is converted into here. Now from here, solving part I'm not going to do, right? So that you are able to do it. Okay, so go to the previous note if you don't remember and try to do that. Also, I'm going to reteach you all of these things again like I did inverse functions. Okay, but those who know how to do it properly, please do it, because I'm going to help the students who came very recently, so that I want them to know all of these things like without missing anything. Okay, so those who are able to do it, yeah, go ahead. Okay, any other questions? Prithvi, do you have any other questions? So please ask any questions from the class test and the homework. Please ask, because you can see these are challenged question. I'm giving you just 3-4 questions, but challenged. I'm not going to give you 100 questions. Okay. So please ask if you stuck in somewhere. Prithvi, you told me you have some questions, so it's
Yeah, the last question in the homework.
last question in the homework. Okay. The trigonometric one, yeah?
Yeah.
So 2 sin x is equal to -1. Okay, so it's like this. Now, what you do? Sin x is equal to -half, right? Like that, so that you will have this here -2 5 to 0, right? So -half is somewhere here, right? -half is somewhere here. So how many solutions you are expecting? 1 here, 2 here, right? So this is x here, this is y here. So we have to be a little smart here. So to find this, you are going to plot this, and then you are going to make, if you have a minus value, I told you, have the positive value over here and find this value. So this value is pi divided by 6, right? And that is from the table, right? Again, we will be revisiting this. You don't have to worry, but understand how to do that. Pi divided by 6 is what you are obtaining, right? And then the red value, the first answer for this -half thing would be -pi divided by 6. So you understand this distance is pi divided by 6. So the answer here would be -pi plus pi divided by 6. Right, so the answer would be minus pi divided by 6. So there are x answers: minus pi divided by 6 minus pi divided by 6. You got that?
Yep, I also need help with the first question, homework.
Okay. Consider fx is equal to 1 divided by x plus k, where k is a positive constant, k is okay, blah blah blah. Also let gx is equal to kx. Okay, find the points of intersection. Okay, bye. So okay, first of all, I'll tell you how y is equal to 1 divided by x looks like. Those are like this. That is how it looks like, right? So now if I want to have y is equal to 1 divided by x plus k, that means you are lifted, and k is a positive number, right? It's given already. So you are lifted the whole thing by k. So it would be, now instead of 0, so you are lifted by k here. So your plot would be like this. Okay, so that's how it looks like. So now now what I will do, 1 divided by x plus k, I will draw separately here. If I do that, like that, okay. Now gx is equal to kx as well. So gx is kx. So it's like this, right? So y is equal to kx. It's a y is equal to mx type, right? Find the points of intersection. So you need to find this one. and find this one, right? So these, you need to find the points of intersection. So you have to give this x value and you have to give this x value. So how do you do this? You equate the equations, right? 1 divided by x plus k is equal to kx. Cross multiply 1 plus kx squared. So it's going to be kx squared minus kx minus 1 is equal to 0, right? So x is equal to k plus 1 minus b squared, k squared minus plus 4k 2k. Okay, so there is the answer. So there are two answers. Now there are two answers. There should be two answers, right? x1 and x2, right? So you can see from the picture. So of course you have two answers. First one would be plus value 2k. Second answer would be the minus value. Okay, so this is going to be x1, this is going to be x2. How do you decide that's x2 or x1? Look at the minus. So minus should be in there. The lower value should be that, right? So hence find the ratio between the distances to the intersection point from the origin. Okay, hence find the ratio between the distances to the intersection points. Okay, so what you need to do, right? You need to find the coordinate here, right? So this coordinate here is x1, right? And suppose y1. This coordinate here is x2, y2. But what is y1? Y1 is equal to kx1. So you can say x1 kx1, right? Here again x2 kx2. Now you can see, now I'm not going to substitute these values here. I'm not going to substitute these values here. So these things you have to learn by experience. If you want, you can substitute. The things are getting humongous, right? So you just leave x1, x2 there, right? And then we will substitute later, right? So I'm asking you to find the distance here, right? So I'm asking you to find the distance here, this distance over here, and this small distance over here. So let's say this is d1, this is d2. So I'm asking you to find d1 and d2, right? So so this is d1, this is d2, this is x1 kx1, this is x2 kx2, right? So d1 would be from 0 0, right? Kx1 squared plus x1 squared square root. d2 would be kx2 squared plus x2 squared square root. So those are grade 6 7 math, right? How to find the distance, right? Y difference x squared plus x difference squared, right? I directly did that. So what I'm asking is d1 divided by d2. So that would be, so essentially I'm going to square it, right? So then I can get rid of the squares in the right hand side. So learn how to play with this math. Okay, then this is what I'm asking. So now if you want to find d1 and d2, what you do is just essentially I'm asking this, right? Essentially I'm asking this. Now the substitution is happening at this level. I'm going to substitute for x1 here, x1 here, x2 here, x2 here at this level, and then I'm going to write the answer after substitution here. That's what I do. Don't do the substitutions here, right? Just leave it like that. No I mean, learn from here. This is what essentially you are going to do in the VCE paper. Okay. Okay. So, okay, that's done. Anything else? Simplification things I'm not going to do. I'm going to teach you like, you know, the core part, okay? Simplification is very easy. Next one. Everyone is okay with these questions? I mean, you got these things, Karthik? You got all of these things? Okay, any other things?
So can you do question 3?
Question 3. Consider fx is equal to this, okay, and gx is equal to log x. Find the coordinate of x is equal to blah 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 blah. Hence, find the distance between them. Okay. Okay. Now, 5 minus 2x squared square root. How that looks like? So I ask you, if you want, you can use the CAS or you can use the Desmos. Okay, because this is a weird function, right? So 5 minus 2x squared square root. So let's go here and see like how that function looks like. That is going to be, okay, square root of 5 minus 2x square. Okay, it looks like this. Okay. Okay, so it looks like that. So apparently it looks like this, right? Now what we have is y is equal to this. So what is this value? What are the coordinates here? Right, so those things we have to figure out. What is the other question? Log 10x. Okay, log 10x looks like this. So there is intersection here, right? So what they're asking is to find this coordinate here, right? So I would say x0, y0 coordinate you need to find. So to find that coordinate, essentially you have to equate the things, right? So into 5 minus 2x squared is equal to log 10 base x. Okay, so solve this, but you can't.
Also square for 5 minus 2.
Yeah, so you solve this using CAS because you can see it's not possible to do it manually, right? So solve it using CAS and you get the answer. Okay, let's try whether we can get that. Okay, so that was what? Square root what? 5 minus 2x squared, then minus, then log 10, log 10x, right? Okay. Yeah. 1.57, right? So x0 value is 1.57. So what is y0 value? So y0 value is log 10 1.57, because once you have that you substitute, right, to one of the equation, right? So this is the solution. right? So I'm asking you to find the distance from here to here. Distance, this point is 0 0, so that distance would be x0 minus 0 squared plus y0 minus 0 squared square root. So it's essentially x0 squared plus y0 squared square root. So x0 squared is 1.57 squared plus log 10 1.57 squared square root. What's the big deal? So use the cas to simplify the log. It's just one step. Mainly when you have a weird function, people are sort of scared, right? But end of the day, you can see once you visualize it, what's wrong with that? It's like basic math is coming.
So could you also do the second question?
Okay. Oh, as a function of x, okay. Okay, second question, ex, how ex looks like. Ex looks like this. It's 1 here. So you need to find the distance from origin to here somewhere, right? I told you when you get that one, take the point x and y here, right? And this is y is equal to ex, right? So if y is equal to ex, so x and ex, right? The function, sorry, minus, right? Function is y is equal to ex. So if you take this coordinate to be x, then this coordinate to be y, then y is replaced by the function given, right? Because y is equal to ex is already given. So you need to find this distance over here. That distance is y minus 0, because this is 0 0 point squared plus x minus 0 squared square root. So y is now y squared, right? So e minus x squared plus x squared square root, right? This is going to be e minus 2x plus x squared square root is d. So now you understand, here you have x and x here, so that means this should be a function of x. That's the answer. I showed you long ways, like, you know, taking this as p and q, and then I convince you, okay, there is no harm to, you know, consider x and y, right? So when I was teaching you the theory, I showed you many ways of doing this thing with more logic. But you know, when we are doing questions, we are sort of experienced, right? So we know what is what. When you have a curve, what is x, what is y, right? Yeah, generally you can take that as p and q and do the business. But x and y, p and q, those are names, right? So you can play with that, right? So those things I discussed with you, and essentially these are coming in VCE. These are like the foundation to VCE. You will see, when you see these kind of log functions, now you are not scared, right? You know how to do it. I mean, these are weird functions. Take the cas and plot it, and then what they're asking, the intersection. So intersection is an intersection, right? Equate it. Even you can equate that in the cas, right? So that skill is what I'm going to give you, because my target is 45 plus. If you can do that, your life is set. So I'm going to help you for that. Okay, anything else?